Good morning all. This is Satish Kumar, Assistant Professor of AC Department. Now let us see the video lecture series on circular convolution. See empathy part. Convolution of periodic signal using linear convolution is repetitive. Convolution takes lot of time. Utilization of DFT for convolution is must. Next one, define part. Define part is nothing but convolution of periodic signals is nothing but circular convolution. Next one, method. X1 of m can be applied to a circular convolution. X2 of n minus m, which can produces the output as x3 of n. This is the need for convolution already given as two sequences x1 of n, x2 of n. We can going to find out your x3 of n. To find the output of a system with the input and the impulse response of the system, linear convolution is used. Circular convolution can be applied for periodic signals, and to obtain the linear convolution through circular padding of zeros are done. The circular convolution of two periodic discrete time signals x1 of n and x2 of n with the periodicity of n. Sample is defined as y of n is equal to x of n into h of n. Summation k is equal to 0 to n minus 1 x of k into h of n minus k. x3 of n is equal to summation m is equal to 0 to n minus 1 x1 of m into x2 of n minus 1 n minus m into n. N represents the time period. If x of n and h of n two finite duration sequence with length m and p respectively, then the length of y of n is equal to x of n into h of n. Input into impulse is nothing but capital N is equal to m plus p minus 1 samples. If x of n and h of n be the two periodic signals with the period n, then the length of y of n is equal to x of n into h of n is also n. The convolution of two periodic signal is also periodic and it is circular convolution. Therefore, y of n is equal to x of n into h of n. Linear convolution can be obtained by circular convolution by changing the length of both signals x of n and h of n by 2n by 0 padding. Now we can going to see the circular convolution of the sequence. Compute the circular convolution using time domain approach for the following sequence. x1 of n is equal to 2, 3, 1, 1. x2 of n is equal to 1, 3, 5, 3. This is the formula which we behind in this circular convolution. x1 of n can be represented only in anti-clockwise direction. 2, 3, 1, 1. Starts from the right side. 2, 3, 1, 1. x2 of n represents same anti-clockwise direction 1, 3, 5, 3. Therefore, y of n is equal to summation k is equal to totally 4 plus 4, 8 samples, which is equal to 4 plus 4 minus 1, which is equal to 3. Therefore, k is equal to 0 to 3. x1 of k into h2 of n minus k. Now we can go into y of 0 is equal to summation k is equal to 0 to 3 x1 of k into x2 of minus k. x1 of n can be written as 2, 3, 1, 1. x2 of minus 1 means can be written in clockwise direction. Totally x2 of n can be represented in anti-clockwise direction. x2 of minus n can be written in anti-clockwise direction 1, 3, 5, 3. Now we can going to multiply the signals. 1 into 5, 5. 3 3s are 9. 2 1s are 2. 1 1s 1 into 3 3. Now we can adding all these signals. 9 plus 5 plus 9 plus 5 14. 14 plus 3 17 plus 2 19. Therefore, y of 0 is equal to 19. Similarly, y of 1 summation k is equal to 0 to 3 x1 of k into x2 of 1 minus k. There is no change in your x1 of k. Therefore, same as it is circular convolution sequence. Already x2 of 1 minus k. Again, we can shifted by one sequence by anti-clockwise direction 3 1 3 5, which can written as already we can write x2 of k can be given, minus n can be given. Therefore, it can be shifted by anti-clockwise direction by one sequence. Therefore, 3 1 3 5, which is equal to 2 3s are 6, 3 ones are 3, 1 into 3, 3, 1 into 5, 5. Now we can adding all these signals, 6 plus 5 plus 3 plus 3, y of 1 is equal to 17. Similarly, y of 2 is equal to summation k is equal to 3 x1 of k into x2 of 2 minus k. There is no change in x1 of k. x2 of 2 minus k, already we can draw 1 minus k. It can be shifted by one sequence in anti-clockwise direction. We can get the output as y of 2 is equal to 2 into 5, 10, 3 into 3, 9, 1 into 1, 1, 1 into 3, 3, 10 plus 9, 19 plus 1, 20, 20 plus 3, 23. Y of 2 is equal to 23. Similarly, y of 3 is equal to summation k is equal to 0 to 3 x1 of k into x2 of 3 minus k. Already x1 of k can be already done. 3 minus k means it can be shifted by one sequence in anti-clockwise direction. Therefore, y of 3 is equal to 2 into 3, 6, 3 into 5, 15, 3 into 1 into 3, 3, 1 into 1, 1. Therefore, 15 plus 3, 18 plus 1, 19, 19 plus 6, 25. Y of 3 is equal to 25. Therefore, final output sequence is equal to y of n is equal to 19, 17, 23, 25. Now we can see the another problem as a sequence in terms of matrix approach. Y of n is equal to 2, 1, 1, 3. Again 3, 2, 1, 1, 1, 3, 2, 1, 1, 1, 3, 2. 2, 3, 1, 1. Again we can shift it by a last sequence 1, 2, 3, 1 and last sequence 1, 1, 2, 3 and then last sequence in your above 3, 1, 1, 2. 1, 3, 5, 3 is your another sequence. Now we can multiply and add all these signals. We can get it as your y of n is equal to 19, 17, 23, 25. For the above sequence, we can going to find the how the answer is correct or not. By using matrix approach, we can verify the answer. Next one, perform circular convolution of x1 of n is equal to 2, 1, 2, 1. x2 of n is equal to 1, 2, 3, 4. Already known, x1 of n can be written in anti-clockwise direction 2, 1, 2, 1. Also, x2 of n can be drawn in anti-clockwise 1, 2, 3, 4. Now x2 of minus n, it can be written in clockwise direction 1, 2, 3, 4. Now we can going to multiply x1 of n into x2 of minus n, which is equal to 2 into 2, 2, 1 into 4, 4, 2 into 3, 6, 1 into 2, 2. Therefore x3 of 0 is equal to 14. Next one, x2, x1 of n can be same as it is. x2 of minus n can be written as it is 1, 2, 3, 4. Now we can going to x2 of 1 minute. It can be shifted the sequence by shifted by 1 in terms of anti-clockwise direction. That's why we can written as 2, 1, 4, 3. Therefore, which is equal to x1 of n into x2 of 1 minus n. We can go to 2 into 2, 4. 1 into 1, 1. 2 into 4, 8. 1 into 3, 3. We can get it as your 1, 4 plus 1, 5. 5 plus 8, 13. 13 plus 3, 16. x3 of 1 is equal to 16. Now, there is no change in your x1 of n. x2 of minus n can be already done. It can be shifted by two sequences in terms of anti-clockwise direction. Right. Now, we can going to multiply 2 into 3, 6. 1 into 2, 2. 2 into 1, 2, 4 into 1, 4. 6 plus 2, 8, 8 plus 2, 10, 10 plus 4, 14. x3 of 2 is equal to 14. Now we can go into find x1 of n, x2 of minus n. It can be shifted by three sequences in anti-clockwise direction. Now we can going to multiply x1 of n into x2 of 3 minus n. 2 into 4, 8, 1 into 3, 3, 2 into 2, 4, 1 into 1, 1. Therefore, 8 plus 3, 11, 11 plus 4, 15, 15 plus 1, 16. Therefore, x3 of 3 is equal to 16. Y of n is equal to 14, 16, 14, 16. This is the answer of circular convolution. Now we can see the difference between linear and circular convolution. Linear convolution is nothing but input signal can be given x of n, impulse response which can print the output as y of n. Multiplication of two DFT in terms of circular convolution. Multiplication of two sequences in terms of time domain is nothing but linear convolution. Multiplication of two sequences in frequency domain is circular convolution. Linear convolution can be defined as y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Here x3 of n is equal to summation m is equal to 0 to m minus 1 x1 of m into x2 of n minus 1 into capital N. Now we can see the assessment. Define circular convolution. Circular convolution, x1 of n, x2 of n be the already two periodic sequence. We can going to find out the x3 of m. Summation k is equal to m is equal to 0 to m minus 1, x1 of m into x2 of n minus m into the whole power. N is nothing but time period. If x of n and h of n two finite duration signals with length m and p respectively, then the length of y of n is equal to x1 of n into h of n is nothing but m plus p minus 1. Mention some applications of circular convolution. It is used in spectral analysis, image processing, video processing to characterize the LTE systems to solve the overlap add method and overlap save method. Next one, determine circular convolution of x1 of n into 2, 1, 2, 1, x2 of n is equal to 1, 2, 3, 4. Therefore, we can get it as your x3 of n is equal to 14, 16, 14, 16. What is the difference between linear and circular convolution? In linear convolution, x of n and h of n be the two sequence can be given to find the output of y of n. In circular convolution, multiplication of two DFTs is nothing but circular convolution. Multiplication of two sequences in time domain is nothing but linear convolution. Multiplication of two sequences in frequency domain is circular convolution. Thank you.